up.
Yeah,
It's
a very convincing.
It's really useful for.
Well, thank you guys for coming.
Trying to like these particular areas of the transition.
Thank you guys for coming. My name is Michael Lockbach. Kind of the host of this thing. It's great to see some new faces. I actually wanted to ask, since there's a lot of new faces, how you guys found the meetup, because we're trying to figure out a good way to communicate when it's going on, what we're doing. There's Facebook, there's a meetup, I know. So who found us with meetup? About Facebook. Any other avenues people found us?
I mean, I heard about it from word of mouth from this guy.
Word of mouth? Okay. That is great.
You texted me.
Cool. Second keeps better than word of mouth, that works. All right, no, that's good. So I want to know which avenues to take. So we have a website now, which we launched last month. I'm updating it to list all the talks that people have given. And I'm going to create a section for speakers where you can have your little bio and your picture on there. If you want to link it to wherever, portfolio or LinkedIn, whatever, saying you've given a talk, you'll be able to do that, and then it'll also link to all the talks that you've given. You've given more than one. Everybody who's given a talk in the past, I'm going to reach out to them and ask them to send me a little blurb about your talk. I've kept notes about all the talks in the past, so I actually know what they are. And hopefully I'll encourage people to talk and get a little something in return. I created a Twitter page for us too as a way to keep people updated. The Twitter page is blocked because I put in the date of birth as a year ago today, and it told me I was too young to have a Twitter page, so. Just the 1-year-old can't have a Twitter page, but it's going to be unblocked soon. I have to send in my ID. So a couple of housekeeping things. We have a hackathon we've been talking about doing. We're hoping to do it sometime this summer, and we have been trying to come up with a list of ideas. So we kind of decided that we want to pick several nonprofits in the community that have some sort of need, technology need, and kind of give back to the community that way. And so Kevin and I have been working on gathering nonprofits. It's actually been kind of difficult to do, but we have a list. So we have the Gold Coast Homes, which Kevin was talking to them. They want to do like a digital tour of Richland during the historic part of Richland, the old houses, and kind of talk about, you drive up to a house, they'll tell you whose house was whose, right, and what's special about that place. 10X, they kind of want a bingo card checklist. So when you're at the event, you can go up to certain vendors or whatever and get stamps for doing things in the app, and then you can get a reward. And that's what you can all pick up. Wheelhouse, they had a couple ideas, a volunteer management tool, and a game app where you can donate to the organization after playing the game, which is kind of like you play and you donate sort of thing. Hi-Ho, which is the children's, Wheelhouse is like a non-profit with bikes and they do a lot of bike events in the community. Hi-Ho is a children's museum in the Tri-Cities, but they don't have a facility, so they kind of operate out of different facilities. They try to do like an actual hands-on children's museum, like interactive learning. They have a need for their website to allow for other members of the community to update or to input their events and kind of make it a portal for events and I think mainly various types of events, and to link back to them and maybe allow registration for those events. They kind of want to be a portal for all things children related. The Arc of Tri-Cities, it's they didn't get back to me. I'm hoping they will soon. They're an organization for children with special needs and disabilities. I don't know what they need, so I'm still waiting to hear back from them. Kind of want to hear back from you guys and see which one of these interests you the most to do a hackathon and which organization you feel strongest about.
Can I later give you another one to add to your list?
Sure.
Okay.
You can add it.
Zarn looking to build a communication app. This would be an all open source. Eventually, well, this is so nonprofit. I don't even have nonprofit status. So,
So Zarn is
Zombie Apocalypse Relay Network, open source, open protocol, decentralized communication network, need a killer app, need something to go on a phone or a computer or something and communicate on it. Something like text messaging or IRC.
Does anybody got any opinions, any strong opinions, any thoughts?
I think that just building an app to do a bingo card checklist, if that doesn't exist on the internet, it should. So this could be something we could build for TEDx locally and then make it available for everyone that's doing local events.
We just have that available.
Exactly.
Yeah, basically.
Does this organization have like a page like
Which organization?
full stack recipes?
There is one. Just has the main website on it now. Yeah.
Is that like after we do some of these, we want to put them into like a get organized underneath, full stack recipes?
Yeah, I'll either go under our GitHub page or go under the organization's GitHub page. The idea is to hand this back to them, right? So someone working product and they can move from there. You had a thought?
I mean, I worked at the Arts before as a volunteer, so I think they're a good organization. That's all I have to say.
Okay, well, that's good to know. Anyone else? Would any of these make you want to get up on the weekend and work on the project?
Well, I mean, I enjoy making maps, so I do want to like help with that.
Yeah. So
Yeah, I know a good bit of like Android development.
What's that?
I know a good bit of Android development.
Okay. Got a couple of votes for TEDx. All right, cool. So next meetup is August 1st. Is Chad here? I've never met Chad. No. So Chad or Rollins will be talking about their trailhead, whatever it is, I don't know what it is, starting out. However, September is open. If anyone wants to give a talk in September, that is Rick's birthday. I had it in my notes to say. So that'll be a special day.
That's a good point.
Yeah, September's
I might have a
great.
good idea for that talk.
What's that?
I said I might have an idea for that. For the talk.
I'll bring your birthday cake if you talk that day.
Talk on my birthday.
I'll bring your birthday cake.
I've been able to brought alcohol tonight. Didn't know that. I appreciate the thoughts.
One last thing. Found a random quote. Found it kind of applicable by Ken Beck. For each desired change, make the change easy, then make the easy change. He's talking about refactoring, so you want to do something, make that change easy, then make the easy change, right? So make that difficult change. A random quote. All right, so who wants to go first? We have speakers lined up. All right, I can do it. Trevor, go first. At the end of this, there will be a vote. I have a link set up, so I'll show you guys. The winner gets this little circuit kit, donated by Compost Space, worth about $100, I think. Sure. Good.
write assembly code for microcontrollers. I like to put 50 pounds of feces in a 10-pound microcontroller. And if you're British, that's a 22.7 kilograms and a 4.54 kilogram microcontroller. So I'm always writing assembly, and one of the things I was doing is I effectively have created over the handful of years a miniature operating system, let's say. I'll call it a framework, but it's effectively a miniature operating system in assembly. So I will make a new device and I will copy in my framework. And the thing is, though, the way I do the writing, I'm always having to modify my framework. And that leads me to, risk screwing something up. I make a new device, I copy the framework, I modify it from the new device, and then maybe I mess up another project by making something that I just don't catch till later, and then 20 work hours later I finally see the one little variable I messed up. How that goes. So anyways, so my approach here is I've got a framework file I created. Actually, I was soliciting. Actually, I wasn't able to make it to the last meetup, but Mike was, I guess, kind enough to pass my question on. But so I didn't get an answer, so I made an answer, and it's on GitHub. The name of the project is Section Insert. So basically, my flow in writing a program, and let's see if I can make this better, is, so here's my framework file. This would effectively be shared between all my programs, and I added some new pre-processor directives, and what I've kind of written is a pre-preprocessor that goes in front of the assembler. This may be applicable to compilers also. So right here, declare memory variables, kind of Arduino. If you're familiar with Arduino, the main style of code is you've got your setup and you've got your things that go over and over and over. So here is my setup section, and here's like the setup code, the splices I'll come back to, set up the interrupts, and then I have the main loop. So basically just do things in here and go over and over and over. Then like in my interrupt, the common thing I have is I have some time-based interrupts that all my devices use. I have a 1 kilohertz section and a 10 hertz section. And then any other interrupt handler, like an I/O port. So this would be a file that once you get it to a point you like it, you do not change. You would then have maybe drivers that get included. So here is a driver file for a serial port. That's really kind of pointless the way it's made, but it demonstrates the purpose. I use an insert directive right here. This is part of the new extension. I give it a macro name, which is that I define it as a macro, and I give it a section that it goes into. If we go back over to the main file, where was my main file of my framework? It would put that memory declarations right here. You would add it right there. And framework. Oh, it's not opening multiple files at the same time. Bummer. My desktop does that though. Driver setup code sticks this macro over here in setup code. Then the assembler just expands out that code there. Insert something into the driver. So this would be a way to not have too messy of a framework file. This is a module I might use between a lot of different devices. And then I have my main program. So I just write something that inserts main program setup, insert it into the section setup code, main program body, insert it into the section running code, and interrupt service routine. Here I'm only going to insert it into the 10 hertz section of the interrupt routine. I also had another issue with the Microchip's MP Lab PIC series, PIC 18 series is what I primarily program in. The assembler does not allow me to do conditional statements on variable substitution. Whatever that means, you can ask me later. I'm going to try to keep this concise. However, I created this generate directive, which will copy all the code in it up to the end generate section and allow me to do these substitutions, and this one will generate numbers from 0 to 7, copy this multiple times and replace those numbers into this. And I've made some pretty messy, but I think elegant workarounds for the fact that I cannot use if statements that have this sort of substitution in the assembler. So, there it all is. The way, so over here on GitHub is the thing if you'd like to find it. Name of it is section insert. And then let me actually just go and run the program. Basically, I created, so on my computer, the hacky way I've shipped it in right now is I renamed the assembler. The main assembler, I then linked where that main assembler was to my program, and then my program, in the Python code, you tell it where the main assembler is, it runs, it creates an interim file, stripping out all those oddball directives that I created that would confuse the assembler, and then passes that to the assembler with every other option that you've given it. So, because I use the integrated MPLABX integrated design environment. So, boom, there it ran. Created this pre-processed file. So that thing where I told you it was generating and replacing, that's what it turned it into. That loop function using generate. So it has all these macros. The reason I do it with macros is because there is a nifty macro substitution language that the assembler does provide. And then down in the main program, so here is, it found the section directory for memory declaration, and it inserted the macro from my driver file. Come down here, the setup section. I also have these slices. Sometimes I want to put code before, after, or between, or a chunk of code if there is nothing in the section. That's what the slice is for. Let's see, that came out of the framework file. The splice, I'm sorry, I thought it was splice, not a slice. So this splice before, in this section, it will put this at the front of it, this in between any piece if there's more than one, this after it, and if there's nothing in the section, it will put this chunk of code in there. So let's get back over to that. So that's what's happened here. And then the driver had a macro that got put in this section, and my main program had a macro. And then in the interrupt, same thing, like the 10th of the second code, main program interrupt service routine. And there's where the driver stuck its macro. So any of these little things, this is just so I could see where my program was doing things. It's kind of somewhere between alpha and beta. I'm actually building projects with it. So it's been basically my approach now to shoving those 50 pounds of feces into a 10-pound microcontroller. So I've got a couple of devices actually on the table there that are built around using that, and I can show you later. I make telemetry devices, all sorts of little remote control stuff and various stuff. So there it is. Cool.
9 minutes and 25 seconds.
Wow, did I get the party?
Real quick, there's chicken alfredo if anyone wants to go get some. Kevin put in the oven kind of late, but done. You want to take a break while Sam sets up? After this?
I didn't make this, that was a tricky debate.
You made the work that got you the money.
Exactly.
So you put enough in assembly there, and complicated program words. I have all sorts of, old graphical menu that has some crypto for strong authentication, shared key authentication, remote control, this whole pile.
So is your preprocessor, could it expand macros recursively?
Well, if my preprocessor doesn't expand macros, it copies the macro name you give it into a section of the code.
And then it uses the standard.
Then it just changes over. Yeah. If you look at section insert on GitHub, I mean the program's only a couple hundred lines, and then I just go in. I just let the main assembler do that. So it's kind of like a pre-preprocessor, just so I don't have to fudge with my framework file all the time when I get it working.
Makes sense.
For those who don't know me, I'm Sam Clopton. I work at Wildland Upstairs, and I'm a software developer up there, and I'm going to be talking about gatsby.js. Gatsby.js is a static site generator for React. What that means is you can use React to statically generate sites beforehand so that they render quickly.
Hey Sam, can you speak a little bit louder for the old folks in the back?
Yeah, no problem. Is that better?
Yeah, thank you.
Okay, thanks. So, why do you want a static site generator? It can increase your page load time. So, your data can be loaded at compile time. So, when somebody visits your site, it doesn't have to go fetch data and then use that data to render content on the page. It's better for SEO, so that search engines can better optimize how to find your site and helps people find your site easier. And it's an easy way to implement server-side rendering using React. And it makes deployment simple because you just have plain HTML files to deploy. So you don't have any custom server wonkiness need. You can use tons of different services to just put a static page and set of assets on it. How does Gatsby work? I don't know if you guys can see this, but you take data sources, you pipe them into your React components, which also have CSS and HTML. Gatsby compiles all that and gives you a production build to deploy. including, index HTML page. So, most importantly, what do your queries look like? Gatsby uses GraphQL, which is a query language similar to like SQL, built for APIs, and you can use this to query data that Gatsby will use to statically generate the site. This is an actual query I put together for a little demo, where it queries content from a WordPress CMS. So one of the things up here, you can hook Gatsby up to backend CMS like Drupal or WordPress, so you can use it to manage blogs, so that you can write your blogs in WordPress and compile them using Gatsby, and then have them static regenerated, so they render quicker than your WordPress site normally. Then you can take the data, type it into a pretty standard React component, and use that data to display content. Sometimes you need dangerous HTML. It's pretty straightforward. Getting it set up, there's a lot of configuration, so there's lots of different plugins for data sources specifically. I used one that somebody already built for WordPress to test it out and play with it. There's ones for Drupal, probably ones for GitHub, ones for tons of different stuff out there on the web. So if you have something you're interested in connecting to, check on Gatsby's site. They have a list of plugins. Take a look and see if there's something you're interested in. When is it useful to use Gatsby? If you're building a progressive web app, that's really useful because you get your server-side rendering for free. And for library documentation, it's really handy. Blogs, any site using lots of JavaScript and React that you need to look. So it's where you can find more information. And I was going to show you a bit of what I put together, just kind of show you how it works. So let me put this over here. Hang on. So I have this simple WordPress blog from, can't see this very well, WordPress.com, where I just created some stupid blog posts to test with. And you can see that here it pulls in those posts, and you can click on them and view them. And they all render really quickly. I can refresh it. Okay. So it refreshes up the page now. And it pulls us all in from the WordPress API, and we're statically generated, so it doesn't need to fetch any of this data. You can also do Reactive stuff. Some of what this looks like, otherwise, is so here's a blog post. So this page right here. That's what this looks like. And you can see my GraphQL query that I had there earlier. And you can also play with what these GraphQL queries look like. Gatsby comes with this nice little thing here. So you can start playing with queries and figure out, and it shows you the data it fetches when you run it. So you can see I have a couple here, and it pulls this data out. And if I put a new blog post up there and click play, you see content for the new blog post. And every time you do make a change on whatever data source you're pulling into, you're going to need to recompile. So in order to pull this in, I have to rebuild the React site. But yeah, any questions? I think it's pretty cool. It uses Gatsby node file for the data. So this is where I build dynamic pages. Here's the GraphQL for that. This uses this plugin to pull that in. So yeah.
So what would be an example of something that you couldn't do using the static site stuff?
Yeah, so something where you're recompiling all the time, where you're constantly making data changes, you want to pull that from a traditional API, not server rendered. So you wouldn't want to pull that into your dynamic pages using GraphQL. You'd be better off just
fetching in your normal API stuff. You could still use Gatsby for the majority of it, but everything that's truly dynamic and not, like WordPress is a great instance for it because every time you make a change, you can have a webhook somewhere that recompiles it, and it loads instantly. You're not changing it all that often. But something like, say you have an e-commerce site, that would be a bad choice for it because every time you add something or somebody buys something, you don't want to be recompiling it. Instead, you do your normal React stuff and you fetch API information to show that stuff. And you can mix that in.
Mm-hmm.
You can. Same site. That's right.
Why is it called gatsby.js?
Great question. I have no idea. And I'm also, talking about React and wearing a member shirt too, so that's cool. Any other questions?
Oh my goodness.
Go ahead. I think that's more.
I was wondering how it will look like when there are new elements to render. Like, so say you have 500 blog posts. Does it render every blog post, or does it know only if it doesn't have already?
Yeah, so technically at compile time, it takes your GraphQL query and builds it at compile time, so it strips that out of your page and inserts the content into the page, and then uses React, create elements and all that stuff to render it. You would have to have something that tells the recompile every time whatever its point of source one changes. It won't know, so because it's serverless. You'd have, if you needed to have it automatically recompile, you'd have to have a server that listens for that change and recompiles it.
But does it go to even all the previous posts that's already compiled?
Yeah. So I believe so.
Yeah.
Because it doesn't know if one of them has been deleted.
Right.
So it has to. And you could limit and all that sort of stuff. Yeah. 9 minutes? All right, so you competition for who does the quickest?
No, there was a prize at the end.
Hey, I'm Jason. I'm a software developer at Kubernetes, and this talk is about Git remotes. So real, I actually start the slideshow. There you go. There we go. So real quick, Git is pretty well known. use it pretty much every day, and I want to talk specifically about remotes because I use Git a lot at home for like my offline backups and stuff. I kind of like offline and online backups are good. And what I found when I was doing a lot of the offline backups that I put it on like a little USB drive or something, is it was kind of important to understand what remotes are and how to basically push them at once. Got it? Okay. So we're going to talk about three things: how to make a new bare Git repo, basic Git remote commands, and more complex example of mirroring. First off, to make a new bare repo is pretty easy. Just do git init -- bare. This makes the new empty repository. It's traditional to make it with a .git directory. The bare repository doesn't have any of the working tree information. It just has the Git objects and the rest. It doesn't have anything else. No local folders, files, none of the local version history, no local commits, and all that stuff. It's essentially what we would get if we were to do like what Git or Bitbucket has or GitLab. That .git file will be cloned down. That's basically what we're creating here in the directory. And this will be important later on. So then we clone the repo. So we go to some other location and we clone the repo down that we just created. Doesn't matter where. Just make sure it's a different directory. So I call them backups. So this is where we start actually working with remotes. So we can show remotes by doing git remote, or I prefer git remote -d. That shows like what it's pointing at. So we can see it's pointing pretty clearly to the backup.git. And now we want to add a new remote. So we do that by doing git remote add. And there's the new remote. We can basically point it at another Git directory. So I pointed it at a different Git repository that I created in a different location. So now we have two remotes: the original remote that still has nothing in it, and a different Git repository that has, I pretty much put all of my stuff, like my PowerPoint, my bio, my little screenshots. I threw that into a folder and put it into a Git repository. That's what that second Git repo is. All you have to do there is specify the remote's name. I chose backup and the path to the remote. So we can also rename remotes. And let's say maybe I think offline is a better name for whatever. Pretty easy to give it a remote name, whatever I want it to be. And it'll change it by itself. Basic stuff. We can also remove an existing remote with git remote remove. We remove the offline remote. Maybe I don't want it anymore. Maybe I want to make a new remote with offline wants to get rid of it, make a new one. Now here's the cool stuff. So if I want to set the remote URL, that's just kind of working with remotes in general. But setting the remote URL, we do a git remote set. And maybe I set it to something that's dumb. It doesn't exist. So it does not exist. Set it to C, does not exist, non-existent. What's important to notice is if there's a bad path here, it won't give us an error message. There's nothing there that says, hey, that location doesn't exist, or that's actually not a Git repo. So there's nothing to stop me and say, you're doing it wrong, or if I were to push to it, bad things would happen. I'm not going to push to it. But if I were to, it wouldn't work because that's not a Git repo that I'm pointing at. That's a folder that doesn't even exist in my hard drive. So one thing to note, there's no warning error message. Just make sure the path is correct if you're doing that. Also, I was looking at this when I was researching this. There's -- fetch and -- push options, because if you notice it was separate URLs to fetch and push. We can specify set and push with this set URL command. So we can set URL -- fetch or -- push, and that would set those individually. That doesn't do a whole lot as far as I can tell, because well, to me it would be very useful because they have to point to the same place. Now, technically they're not pointing to the same place, but whatever we push has to immediately be the same as what we would immediately do a fetch right after. So for most people's purposes, that's not helpful because if I were to have this pointing in two different places, then they would have to come some automatic copy over. If we wanted to fetch from one place and push to a different place, we would actually use two separate remote URLs, two separate remotes like we were doing here. So if I wanted to say only pull from here and do my work and only push to some other good place, so basically a single direction workflow, we would use two separate remotes. We would use separate fetch and push URLs. Okay, so more complicated is mirroring. Basically what it says in the 10, we want to duplicate refs across remotes. And that's pretty much, again, the Git-like way to essentially copy the entire .git directory. We could do it by hand by, right-click copy, right-click paste. It's the same, pretty much the same thing, but it's the more Git-like way to do it. This is primarily used for a complete backup of the repo. If we want the new repo to look exactly what the original repo does, that's how we would do it. And this has parallels to other Git commands. Git push has a dash mirror option, and Git clone has a dash mirror option. And what we're about to do is pretty much going to hard code the setting for push and clone. So here's how we would add mirror. We are going to do git remote add dash mirror equals push, and then set it to the backup directory. Oh, one other thing is I switched directories here. So I switched from the other remote to Git backup to Git backup. So I want that actual repository to push, basically copy everything down to the new repository that I created a couple steps ago. So everything in the main repo is going to pretty much just overwrite everything in the old or the new repo. And that's, and here's pushing to the mirror. So when I do that, it basically pushes a bunch of new branches out to the mirror. And we do this by doing a git push and then give it the mirror's name. So I call the mirror backups in the previous step. When I said git remote add dash mirror equals push, and I added a new remote called backups, and I gave it that remote URL. That's basically the empty Git repo. So when I push to it, it makes a bunch of new branches. It makes basically all of its defaults, Git information gets overridden by my actual repo's branches, which I don't have any besides this 14 master. But if I had other branches, those would also be pushed out to the new repo. Here's the updated mirror on the other side. So if I were to pull it down, it basically pulls down from what would be an empty repo to essentially what is an exact copy of the first repo. So that's a pretty cool way to using Git to copy one to the other. And I prefer to use this over something like rsync because rsync is also capable of the complex stuff that I like to do with my personal backups, but it doesn't have version history attached to it. For me, which is it's really important to have that because if I go back 6 months or a year or something, I don't know why did I remove this file from my personal files, and I left a comment that says this is one. There's also, you might remember, I did a Git add mirror push. There's also a Git mirror dash fetch, or a Git mirror dash fetch, which mirrors all remote threads with the local repo. This is why the bare repo is important, because if we're doing a mirror in the other direction, if we're doing a Git fetch from a mirror, it'll override all of our local commits, local history, local working tree stuff with whatever's on the remote. And that's why we need to use a bare repository, because it doesn't have local history, so it can't clobber our local history if it's a bare repo. I think that's the idea. I think I had a slide on, no, I was not. I had a slide on, I deleted it or something. Real quick, here's a list of all the commands I use. So we have the new repo, so get init dash bear, and git clone to get the copy of it down. And then these are some basic remote commands. So git remote, show remote, git remote dash b shows more information. We can add, rename, remove, and then set the URL. There's also the git dash URL, which to me is pretty much the same thing as git remote dash b, but it has different information. And then add the actual here, git remote add dash mirror equals push. So, any questions or comments? Yes.
What are mirror remotes used for?
Again, pretty much just a hard copy of the repository.
Okay.
For me, that's what I would use it for. So basically, that way I can say, if I have two locations, like an online and an offline backup, I can plug in my USB drive and set the remote with set URL to, C:E or C or E, whatever the USB drive is, letter is. Give it the path to my bare repo on my USB drive, and then I can either git push all or git push whatever I need the remote to, and then I can basically, whatever I feel like, or scriptedly perhaps, hard copy the repository over.
So to push to your main origin remote and your remote at the same time, you can get push all.
That was something I don't have a slide for, but that is basically the way I would do that is there's a git remote, there's a way to add a second URL to the remote, and then you basically push that URL. The recommendation that I found in my research was to say, make a new remote and call it all, something like that, and then that all remote has URLs for all of your remotes together. Good question, thank you.
Does mirror automatically sync or do you have to tell it to sync?
Yes and no, so it doesn't automatically do anything. It basically clobbers whatever's there, all the rest of their head, branches, whatever, get overwritten by whatever you push out to them. So, a grain of salt, maybe use with caution.
we got 2 more talks. Ian will go next, and then followed by Rick, who's running away.
Than developer, but I dabble, and one of the tools that we use at work is called Kubernetes. There's this concept of cloud native. Cloud native kind of involves using technologies that promote kind of these 4 main ideas, where you have microservices or containers that are dynamically scheduled. The tooling allows you to be kind of open and give some extensibility to your application deployment. Also, if there's APIs defined to interact with the system that's trying to manage your apps. And then minimal barriers to application lifecycle management, so that you can kind of do rapid deployments and updates as needed. There's a foundation that tries to help promote this. It's called Cloud Native Computing Foundation. They were founded in 2015. They kind of serve as the project steward for the ecosystem they've started to kind of put together, and they also play the role of kind of a liaison if you want to become part of the group. So if the only official one right now, a part of that, at least as of fairly recently, was Kubernetes, but they're looking to kind of officially bring in more applications here soon, as far as I understand. If you'd like some more information kind of about the general organization and all the things that they do, you can go to cncf.io. So this is kind of the landscape that they've put together, all the different applications and services and backends and front ends and all kinds of things that kind of started to gather. There's all kinds of vendors and all these different layers and pieces that all kind of fit together to form this kind of mass grouping of technologies. And again, they have this reference kind of at their main site there. But let's see. So, do many of you work with containers or containerized applications? Okay, so some of you. So as you kind of start working into containers, as you're doing your development with websites or backend or front end, however you end up needing to do that, you kind of start to realize that as you want to push this out to production or have other people use your application, there's some things that you kind of want to have backing it. So it kind of falls in line with some of the cloud native computing ideas. So you have your common REST API to manage all your services. You kind of like to have some high availability, so if your app dies for some reason, or you want to have it run in multiple data centers or anything like that, the platform that you're running on should have some sort of high availability to it. Should kind of facilitate some DevOps best practices. So as you're developing, you're using all your communication tools. I kind of consider Git as more of a communication tool. So you're developing and you're saving your stuff, but you're also, that tool provides you a platform to be able to communicate with a team of people or open source developers to kind of contribute. So just as an example, let's see, should be focused. So the platform that you're running on should probably be more concerned with the service you're actually trying to deploy and not where it's running. As a developer, you don't necessarily care. I just want my app to run, right? So that's kind of a need that you're looking for there. Applications should be portable and modular. So as you're building apps, you want to be thinking kind of, okay, well, how is my app, how can I plug different things into it easy, like just individual components, and how do I break those out and make it scalable? That's just kind of, you're not just building this one container, this special snowflake. You want to make sure that as you're developing this tool, that it's able to kind of expand from where you're starting from. Scalability, auto-scaling. So as your demand increases, so say you're deploying a large app that a company uses and there's a high demand, it wants to be able to, you need to be able to auto-scale that app up so that as you're hitting requests to it, it will add various containers to be able to accommodate that load, and then maybe scale back down when the load goes back down. So kind of enter Kubernetes. Let's see, the race. So Docker came out in 2013, and kind of since then it's been kind of a challenge to kind of wrangle all these containers and make them portable and make them, well, not necessarily portable, that kind of goes along with Docker, but just kind of a way to manage the containers. So there's some really big players that are actually backing Kubernetes now. So it would be like Amazon, Microsoft, Red Hat, Canonical, and then it's also become the standard. Basically, everywhere you go on cloud services, you're going to run into Kubernetes kind of out of the gate. That's what they're all kind of using now. So just a couple ways that Kubernetes is able to meet those container needs as you kind of go forward in your development. It provides a common API, and you can access that with the kubectl tool. I kind of provide this bit.ly link directly to the page. In case you guys want, I can give it to you. But it was a lot longer than this, and I thought I should show it. So HA, pods are automatically rescheduled. There's native load balancing, and then you can also do rolling updates and rollbacks. So as you develop your application and you want to make changes, you want to have like a dev release and a prod release, you can actually do a temporary install and say, okay, this looks good, so let's promote that to production. So you just kind of do this rolling update, dev takes over the place of production, and as it's done deploying into production, it kills off the old production version. So it's really smooth transition, very short time to change over. Kind of the DevOps best practices. It provides you some environment isolation with namespaces. It's actually fairly easy to integrate CI/CD pipelines directly into the platform. So you can build your app and deploy your app all in the same environment. Not that should. Let's see. Service focus. So there's an API server that kind of manages all of your various runner or nodes that run all of your applications. And basically you say kubectl deployment go. That's really generalized, but and you don't necessarily care which node it's running on. I mean, you might have a scenario where you have a node that has like solid state drive, there's a spinning disk, you need some performance for databases or something like that. But besides that, you don't care what node they're on for the most part, just as long as the service is available. Let's see, proactive monitoring. Kubernetes provides some kind of built-in monitoring features. So Prometheus is kind of the main go-to performance statistics gathering tool that they use. And pods will automatically dump those statistics straight into a Prometheus server, and you can display that with Grafana or whatever to kind of get some insight into what your application is doing. I got the warning, sorry. I'll try to really sorry. Let's see, service focus, portable, modular, kind of like what I was saying before. You can use config maps to kind of build your app and kind of upgrade that over time. There's this concept of pods, so a pod could be any number of containers that kind of act as a service, or that all kind of work together. Scalability. You can kind of control the scaling on a per node level or on a cluster level, and you can run containers that kind of act more or less like a daemon service, but I'll try to. So how do you get started? I have this link. If you want, I can get it back for you again, but Kubernetes.io has a really good tutorial. It's interactive, and they run through all the different pieces of Kubernetes, how to run like a local Kubernetes thing on your box in your development environment. That particular tool is called Minikube. So if you start developing an app and you say, oh, okay, it's running in my Minikube, well, you can actually deploy that basically as is directly on a normal Kubernetes cluster. It's just kind of a little mini environment. Helm is kind of the buzzword right now for kind of application management. So if you're familiar with Yum or apt, this kind of provides you an application, a package manager for the Kubernetes environment. So, let's see, and I'm assuming I don't have time for anything, but I do have some interesting slides. If anybody's interested to kind of see what happens when you do Minikube, maybe some Helm stuff, anyway, I can show that if you guys would like. But I think I'm probably out of time. So. What?
30 seconds, go.
Okay. Okay, Minikube start. Okay, there's some prerequisites. I'm not going to go through those right now, but if you go through the tutorial, you can get this to get it set up. So then you can do Minikube start. You can do Minikube status, see where it's at. Minikube logs will show you the kind of stuff going on in the background. You can do kubectl get pods all namespaces. This is the initial look of what you'll see. This is eventually what you see.
Time!
If you do a Helm init, it sets up Helm for you, so you can kind of do your package stuff with Helm. You can add things like GitLab. You can add GitLab as a repo, and that gives you their specific Helm charts to be able to launch GitLab server and Kubernetes if you like. From there, you can run a Helm repo update. You do Helm installs this, basically. That's not going to give you what you want. I discovered that while I was sitting over there. But this is the general idea, right? You do a Helm install your app, and it just kind of launches it. So there's a couple other details there with some variables. But if you Minikube dashboard, if you set this up in your config, you should get something like this. And it's basically a dashboard that kind of shows you the running status of your cluster and what's going on. So anyway, I think that's all I have.
I have a question though. So you mentioned like balancing on like the node level, that cluster level. Is
Yeah.
that basically a separate node that handles the load balancing, or is it part of the Kubernetes environment?
It's actually deployed on each node as a data set, and that helps balance the services out.
Okay.
It's called the
So each node can contribute to their own node balancing.
what's that?
So each node can contribute to their own node balancing rather than having a dedicated.
Yeah.
Oh, cool. Okay.
Sorry. Back there?
So what does OCI compliant mean?
Oh, I didn't even get to talk about that. So, okay, Docker has kind of had the market cornered in terms of how you structure your images for Docker images or container images. There was an initiative to try and decouple that from Docker, and that's called OCI, and it's the Open Container Initiative, and that involves the way that you create that it's a standard to do both images and container runtimes. So if you're an OCI compliant, you're not necessarily beholden to whatever Docker decides to do. You can do your own thing, and various vendors that are a part of the CNCF will all basically be compliant. You can run this and that, and everything will just kind of work together. Sorry.
Where'd you get that cool Slurm sticker?
Oh, I got that. So some of my coworkers went to high performance computing, and they brought back a bunch of swag, and some of them was the Slurm stickers. So yeah, that's where that particular one came from. So, anything else?
Excellent.
Sorry. Thank you.
Probably will. That's the power of USB-C, ladies and gentlemen. Apple had nothing to do with that. It's all USB-C. All right, so we're good to start then? Okay. So let's just assume for a second that you've drank the Kool-Aid that Ian was selling, and you are all in on containers. This is kind of a prerequisite. Containers are actually pretty amazing things. So at the high level, everyone here familiar with Docker and containers? About 50-50. All right, so we'll go into this real quick. So a container is kind of like a VM, right? It lets you run your operating system on another operating system, but it's different in the way that instead of actually running in a completely separate, memory space, it kind of just overlays on your existing Linux operating system. And why this is cool is really it's just much better for performance. You can run literally hundreds of containers in a single operating system, whereas if you try to run hundreds of VMs on on a single machine, it's gonna just crash. Right? So containers and the other thing containers are useful, the reason why you want this kind of like overlay operating system or your own operating system is this operating system can behave as if it's the only operating system on the entire machine. So you get isolation. And where this is magical is when you've got a large scale enterprise that's got a bunch of different organizations within the enterprise that are all building their own things. They're all using their own tools. They're all using their own libraries and programming languages, and even they're using their own freaking operating systems. They can all pretend that this operating system one is deploying is dedicated only to them and nobody else. So what this allows the central organization that is responsible for deployment and operations and management and keeping everything running, they don't have to serve every single organization individually. They can just run all the containers. They can just dump them all in one place, run them all, and everyone gets what they want. Right? It's actually Docker is probably one of the most important things to have in computing, since the floating point operating unit. So as Ian pointed out, so once we discovered containers, it's like, oh crap, now we need a way to just dump all these containers in one place and run them all and schedule time across them and blah, blah, blah. And that's where Kubernetes is kind of emerging as the leader in the, let's, take 100 machines and schedule all these containers across these machines and run, right? So apparently I have not given my laptop enough attention. All right, so that's containers in a nutshell. So this lightning talk assumes that you like I said, you've already bought into containers. You've built your My Little Ponies e-commerce website. It's running. It's making good money. But you need to update it frequently, right? So you've got some interactive My Little Ponies chooser applications, mini applications in your system, and you've got a bunch of developers that are like, you're building out your My Little Pony customization tool chain, but every time they change something, they've got to rebuild, they've got to recompile their code, they've got to rebuild the container, they've got to push that container to the Docker registry, and then once that thing's pushed, then they've got to deploy that thing out into production, right? These are a lot of steps, and if you're asking a developer to do this over and over again, the average developer commits code to Git like 8 times a day. Let's assume you have 10 devs, which is reasonable if you're a My Little Pony shop. Then you've got 80 times a day, people are literally just stopping what they're doing, rebuilding this container, pushing this container out to dev, pushing it out of production, blah, blah, blah. It's going to get old. Devs are going to be very unhappy. You're wasting a lot of time, and, very valuable ping pong or drinking time for both. And that's how you lose software engineers. So you got to keep them happy. You got to be able to automate all this stuff. Luckily, this stuff is incredibly automatable, and that's where GitLab pipelines come in. So GitLab, if you're not familiar, is kind of an alternative to GitHub. If you're not familiar with GitHub, there's actually nothing I can do for you. So GitLab pipelines or cloud-native infrastructure as code GitOps for continuous deployment on immutable infrastructure using containers. Or if you're playing Buzzword Bingo, you just won, congratulations. If you've never been to a conference, probably. That's cool. All right, so basically, what are GitLab pipelines? So as I mentioned before, when you're deploying to production with or without containers, you usually got this step where you've got to build your code, you've got to move this code onto the thing where the internet is pointed at, and then you want to point the thing to the thing where the internet is pointed at and make everything happy. So a pipeline will do this in multiple stages. so you want to build your code, you want to test your code, make sure nothing's broken, and then you want to take that code, mix it in with all the other potential code, make sure it all plays well with all of its friends. That's the integration test. Bam, you've got a pipeline, right? You've got a lot of steps that need to be happen, that need to happen in order, and there's probably, in addition to this, there's probably, 3 subtasks for every box that's there, right? So this, as I said, would get very, very old if you're doing this all by hand, which a lot of companies actually do that. So, another pipeline is very similar, right? So instead of integration testing, you want to integration test and you want to deploy out to your staging or you want to deploy out to production. So all of this pretty much revolves around this whole concept of just, building shit, where you're just basically running the same commands over and over again. So you don't want to do it by hand. You want to make an army of robots do it for you. So GitLab, while it is a Git server, it will let you, collaborate with your team and manage issues and blah, blah, blah. What's pretty magical about GitLab is that it does offer this concept of pipelines, which in itself is all based around containers. So it lets you describe this kind of language that says, I want to describe this series of containers, I want to define what they do, and I want to allow, I want to be able to stack them and run them serially and let them pass artifacts from one container to the next container to the next container, and thus having a very happy collaboration among my army of robots. So what does this look like exactly? So the sun is not my friend at this point, but basically, if you're running GitLab, right, which is just a website, you can deploy it on your own infrastructure, or you can use GitLab.com. Basically, you have YAML. Everyone familiar with YAML? So YAML is yet another markup language. That's what it stands for, right? So, and this is basically, you're literally just, you have a hierarchy of text, and the hierarchy is literally just defined by indents. And somehow somebody thought this was a good idea. It's a good idea, but either way, it works. So this is it. So basically, at the very top here, what we're saying is, I've got a pipeline and I've got 3 stages in it: test, build, and publish. Right? So I want to test. I want to test my code, make sure it passes all my unit tests after somebody checks it in. And then I want to build my code. Obvious, unless you work in dynamic languages that don't build them, whatever. Just pretend that's totally fancy, whatever. And then publish, right? So I'm going to actually take all my code, package it up, and publish it out to a Docker repo so that my production system can consume that container and run it and give my little ponies to the world. So those are the stages we predefined. So now we're actually going to describe each stage in parallel, or in serial. So the first one is image, Rust lang, Rust nightly. So what we're saying is, I want to find a Docker image under the namespace Rust lang called Rust nightly. If you're not familiar with Docker, that's going to make no sense at all. If you're familiar with Docker or not familiar with Rust, you're going to be wondering, what am I doing? But anyways, so we say image. So this is actually the container in which this whole job, this test job is going to run. And it's stage test, which we described as above. So this is describing the test stage that we're going to run. These are variables. These are actually environment variables that we want to pre-describe. If we get time, I'll talk about that. But basically, yeah. And then the script. This is actually what is going to be executed inside of this container here, and then magic happens, right? So after this happens, assuming this last step completes, well, actually any of these steps, all they must complete with exit code 0, right? God damn it.
Magic of USB.
I have a seriously high maintenance laptop. All right, so I should have turned off screensaver. Anyways, okay, so all these must exit code 0, assuming that does. This stage is complete. It's going to move on to the next stage, which is build. So inside of this stage, we're actually going to build our final product that is going to produce an artifact that's going to be moved on to the publish stage, right? Pretty easy, right? So same thing happens. We're going to run it inside the container that we choose. We're going to name it build because we lack originality. And here's our script. We basically just get the appropriate dependencies, build it, bam, and then publish. So here we're going to run inside a different image, right? These ones I was running inside of Rust. This one I'm actually running inside of Docker Git. Why? Because I want to do Docker stuff and also Git stuff. So you can't really see this because of the whatever those things are. But suffice it to say, I have this stage called publish. It publishes things to my Docker repo so that I can run these things in Docker or Kubernetes later. Okay, so I was actually going to show you a live actually working copy of this stuff. I'm out of time, but I'm just going to do it until Mike tells me to shut the hell up. All right, so
That's what I did, if you're gonna refresh it. I won't count it against you.
all right. So there's a few extra bells and whistles in an actual living working script. So one cool thing that you can do in a live GitLab pipeline is you can save the before script. So I want to run this for every single one of my pipelines. I want to do this task before all of my pipeline steps run. So I'm going to do test, publish, and deploy. And at the start of every one of those, I'm going to run this, right? So really what I'm doing here is setting up my SSH key environment, which if you've ever dealt with a multi-tenant environment, you've got to deal with authentication, and it's a drag. Luckily, there's a pretty easy way to deal with this stuff. So there's that. You can also have global variables, so global environment variables. So in our particular company, we actually do use submodules quite a bit. So this actually just tells this environment variable to tell Git every time you clone, please clone recursively. Thank you. Oh, services. So this is like the power user, like this is like the He-Man feature of GitLab services. So in addition to your whole pipeline process that you're using when you're deploying, you can actually say, you know what, when I'm running my tests, I actually need a Cassandra server to be running and available to these Docker containers while they're running. Or I need, in this case, I actually need an MQTT server called Mosquito to be running while I'm running my tests. So this can actually spin up these services beforehand in Docker containers, networking them all together to make them available to your services you're testing and make them go, which is kind of cool, right? So we make services available, we're testing. This is the other fun piece. So I mentioned before that these things are run serially or in parallel depending on how you specify dependencies. They can also pass artifacts from one container to another. So Docker by default isolates things, makes them think they're the only thing in the system running, but sometimes you want to be able to actually produce something and make it available to the next thing. So artifacts allow you to do exactly that. So they'll say, I'm going to, in this path, the result of this compilation stuff, I'm going to produce this thing and I'm going to pass it to the next. I'm basically going to chain this file to the next container that runs after me. So basically we've got a test and a publish step. Test, in addition to testing, is going to produce some bits that the next stage, publish, is going to actually consume. Right? Publish. Right? And then you guys have seen that before. The only new magic here is that we've got some specialized variables, because this particular container actually doesn't deploy to Kubernetes, it actually deploys to Docker machine, which is a kind of a Kubernetes light, really light. But it lets you kind of wrangle groups of containers on an easy way. I guess I've gone way over my time. So if anybody has any questions, let Mike know. No, sorry, go ahead.
So with the services, with Cassandra, is that all you have to do to get the network? Does it take care of all the magic networking connectivity on its own?
Yes, so what's pretty cool, and it works a lot like Docker Machine if you've ever used that. So it actually makes a machine and makes the DNS name whatever you alias it as. So I'm using Cassandra image 311, the host. So if I address a query to, in this case, Cassandra, it will actually reach the Cassandra server. And the same thing, if I address to host Mosquito, there actually is a DNS name called Mosquito available that addresses it to that virtual NIC inside the little Docker network.
Thank you, that's cool.
It makes it ridiculously convenient.
Docker is what, mandatory to make password.
Yeah.
So I don't see where you're copying your source code as a container. Is that just automatically done?
Excellent question. Next question. No, so let's see, let me look at this thing here. So implicit in, I actually should have probably shown that. All right, let me back up here for a second. I didn't do it. clear the sun. There we go. All right, so this lives in a Git repo inside GitHub. So it will implicitly, to answer your question, clone this repo into every single container. So if I want to clone additional repos, I can, but by default, it's going to clone this and every submodule that this uses. And this does actually use submodules. So this guy here is a submodule. So it's going to, because I set that environment variable to automatically recursively clone submodules, it's going to actually clone this and everything into that container before it does its work.
So grab the action to be config and clone itself.
Let me go back to that.
We can have a key to clone.
So it is, because this lives inside of a Git repo, it's going to do everything. It was actually very important probably to talk about. So this file lives in a Git repo. Every time I check something into that Git repo, GitLab is going to analyze this file and say, do I need to do anything after they've just checked in, right? And so I can say, at this point, it's going to say yes. It's going to actually attempt to execute these things, but I can actually tell it. Let me see. So for instance, in the publish stage, yes, which you can kind of actually vaguely see here, it says only master, and this is kind of a cool thing. So if I commit to this repo, but only in the master branch, do I run this particular block of code, right? But when I commit to some other branch, like a test branch or a development branch, it's not going to run this because this is only happening to production. So I don't want to deploy to production when I'm committing against some sort of dev or test branch. So GitLab itself will look at this file and say, do I need to run anything every time I commit code? And it's going to run. It's basically going to clone in this whole repo and execute these commands against this code repo every time it runs. That was an excellent question. Yeah?
Where are the pipelines executed?
So the pipelines, excellent question. So GitLab itself maintains its own army of robots, which are actually VMs or bare metal machines that run Docker containers. So every single one of these blocks, right? So these services, as well as this block, this test block, the build block, the publish block, are all going to run their own Docker containers spun up by GitLab itself when I commit code. And then there's also this really awesome feature called Auto DevOps that GitLab has, which will let you not just spin up in a local Docker instance on the machine, it will actually spin it up in a Kubernetes cluster in the same automatic transparent way. It's kind of ridiculously awesome.
Yeah, that just came out like officially stable like the last 2 builds. Pretty cool.
Yeah, it is actually fairly convenient if you've got a Kubernetes cluster handy. Or no problem. So, any other questions? No.
Cool. Thank you.
All right.
Back to me. All right, so one more piece to this. We have to get a phone or a computer. Go to that link. Will be often developed for all 5 talks given. I believe in the winners, so inherently I believe in losers. And we're going to have one winner today. The thing that I didn't mention to the people giving talks is if you win, you're obligated to give an hour-long talk on this in the future meetup. So while you guys are doing that, this was our 1-year meetup. or 13th actually, so started last July. So thank everybody who's been coming, will continue to come. It's been really fun doing this. Thank you everybody who brought food to the delicious. Need some music done.
I can seriously spell music.
Who wants to be known here? Well, I guess so. Everybody done? Anybody not done? Anybody listening? Is anybody not done though? One more person? He's a deciding vote right here. There might be a tie. Do you need the URL?
What's the URL? I'll get the URL. What's the URL?
I put it back up. I just see it.
Have you ever known me to troll? Never. That's what we do.
We got it there. Congratulations, Casey. Sorry. All right, there's plenty of food. We meet August 1st, I think I said. If you want to give a talk, it's on the website, you can submit a talk. September is open. And grab more food and thank you for coming.
You all grew on these. What's the website again for, is it like software?
Fullstacktc.org.